Hey, welcome to The Explainer. Today, we are going to pull back the curtain on a super important concept, something that's really the backbone of modern software frameworks like Spring. We're talking about dependency injection.
So here's our game plan. First, we're going to look at what I call the tightly coupled problem. Then we'll talk about the big idea that fixes it, inverting the control. After that, we'll dive into how that actually happens by injecting the dependency. We'll compare the two main ways to do it, constructor versus setter injection, and finally, we'll get to the good part, the payoff, all the key advantages.
All right, let's kick things off with a question that I think every single developer has felt in their bones. You know that feeling, right? You make what you think is a tiny, simple change over here, and suddenly your whole application just explodes in a chain reaction of errors. It's a nightmare. Well, that tangled mess, that's exactly what we're here to talk about, and more importantly, how to fix it.
So what's actually causing all this pain? Well, this whole code spaghetti situation comes from one core concept, tight coupling. This is the root of the entire issue, so let's dig in.
Okay, so what does tight coupling actually mean? Well, think of it this way. In the, let's call it, traditional way of writing code, your objects are, well, they're kind of control freaks. An object needs something to do its job, right? Another object, a dependency. Instead of just asking for it, it insists on creating that dependency all by itself. It knows exactly how to build it, and it's completely tied to that one specific version.
You know what? Let's make this super simple with an analogy. Imagine you have a car object. A car needs an engine to work, obviously. So, in the old way, the code inside the car object literally says, new engine. It builds its own engine, right there on the spot. And what's the result? Well, that car is now permanently stuck with that one specific engine. You want to try a V8 instead of a V6? Or maybe an electric motor just for testing? Nope, sorry, can't do it. The whole thing is totally rigid.
Okay, this is where things get really interesting. This is the aha moment. To get away from that super rigid design, we have to completely flip the script. And the solution is this really powerful idea called inversion of control, or IOC for short.
And this quote really nails the core idea. What inversion of control means is that you, the developer, stop being responsible for creating all the objects and wiring them together. Instead, you hand that job over to a framework. The framework is now in charge of creating objects, connecting them, and managing their whole life. The control is literally inverted. It goes from you to the framework.
So let's go back to our car. In this new world, the car object just asks. It says, hey, I need an engine to work. It has no idea how to build one, and frankly, it doesn't care. That's not its job anymore. Now, some external factory, which is really our framework, hears this request, finds the right kind of engine, and just hands it over to the car. And the result? Now we have a super flexible car. It'll work with whatever engine the factory gives it. Awesome, right? Okay, so inversion of control is the what. It's the big picture philosophy. But how do frameworks actually do this? What's the mechanism? Well, that's the how, and it's done using a very specific design pattern called dependency injection. And there it is, plain and simple. Dependency injection, or DI, is the pattern that makes inversion of control happen. It's the action of an external source, like our framework, literally injecting or handing over the things an object needs, its dependencies, instead of the object making them for itself.
All right, so the framework is going to give our objects what they need. Cool. But how does that handoff actually happen? Well, there are two main ways to get the job done, especially in a framework like Spring: constructor injection and setter injection.
Let's break these two down. First up, constructor injection. This is where the dependencies are passed in as arguments right when the object is being created, in its constructor. The big plus here is that it guarantees the object is fully formed and ready to use from the get-go, and its dependencies are locked in. They can't be changed later. Now, on the other side, you've got setter injection. This uses regular methods, something like a setEngine method, to give the object its dependencies after it's already been created. This is definitely more flexible, and you can even swap out dependencies later on. But the downside is there's no guarantee the dependency will be there when you need it. The object could be in an incomplete state.
So the big question is, which one should you use? Well, here's a great rule of thumb. You go with constructor injection when a dependency is absolutely 100% mandatory. A car has to have an engine. It's not optional. But you'd use setter injection for things that are optional or things you might want to change later, like a fancy GPS system or a bike rack. The car works without them, but they can be added on if you want.
Okay, so we've gone all the way from a really annoying problem to a big picture idea and then down to a hands-on pattern. So, why? Why do we do all this? Let's talk about the payoff, the real-world advantages that make developers love this stuff.
And here's the laundry list of goodness. This is the why. When you use dependency injection, your code just gets better. You write way less of that boring glue code that just wires things together. Your components are nicely decoupled from each other, which is a huge win for testing. You can easily test things in isolation with mock objects. All of this leads to a much cleaner application design. You can reuse modules all over the place. And maybe most importantly, your code becomes so much easier to maintain and change down the road.
Which brings us to this final thought. The name of the game is inversion of control. And I know, that sounds like you're giving up control, right? But what we've seen is that by letting go, by letting the framework handle the object creation and wiring, you're not actually being controlled. You're being empowered. You're gaining the freedom to write code that's more flexible, way more testable, and a whole lot easier to live with.